So shall we start? Okay, and remember, don't forget to what is that? To fix it on the board. You have to press for a while. Okay. So you remember last time I was towards the end of the lecture I was writing down the derivative of x square, and I showed you that it is 2x. Okay. And I think also I had done for x to the n, I had done or not?
Yes, yes.
For n positive integer.
Yes.
So I had shown that d over, I don't like it.
You can use the other end of the pen. You can use the other end of the pen for the bite.
Just like this.
Yes.
Really?
Yes.
Nice. If fx is x to the n, it looks beautiful also. Where we saw that n is a positive, it will always be white. Okay.
No, you can change the color there.
Okay, so n is a positive integer. Okay. Then f prime of x is n x to the n minus 1. Okay, so we had shown this result for n equal to 1, 2, 3, 4 like this. Okay, any integer, and that's what I used here. So x square, so that gives you 2x. Now today let's start looking at, also I'll just to get you used with the notation, remember this we can write as d over dx of x to the n. Okay, that's the same thing. Now let's find out the derivative of 1 over x. Okay, how much is that? Now I cannot use that formula directly because I have not shown you, I mean we proved it only for integer n. So we have to see what this is. Okay, so let's do that. So what's the function here? Function is 1 over x. So what is d over dx? It is, remember I should take the function at a neighboring point, which is fx plus h. So in this case, what is f of x plus h? 1 over x plus h. Okay, so I get 1 over x plus h minus f of x, that's this, divided by h. That's, instead of dividing by h, I multiply by 1 over h, and then I should take limit h going to 0. Okay, so you should take the limit h going to 0. This is what we should evaluate. Is the procedure clear? It's just we are repeating the same things which we have done earlier. What is that? 1 over h, let's multiply these two, so that's x minus x plus h. So this is what happens, divided by x times x plus h. Now you see on the top what I have in the numerator, it's minus h, right? So as h goes to 0, the numerator becomes 0. Here the denominator will always become 0 because there is always in the formula for the derivative you have 1 over h. Okay, so this is equal to, or maybe I think I can lift it up, right? Yeah. Oh, this looks beautiful. Okay, so what is that? And of course I have to take the limit h go to 0. This is, the numerator is minus h divided by h, that is minus 1 over x into x plus h. Okay, so minus 1 in over x into x plus h. See, what happens is the numerator becomes 0, the denominator also becomes a 0, but the ratio is not 0 in that limit. Okay? Remember this. Now here I can put, when I take h goes to 0, this is 0, no problem. There is nothing like 0 over 0. So this is minus 1 over x square. That's the result. So d over dx of 1 over x is minus 1 over x square. Okay? I'll give you, so that we should write down somewhere. So d over dx 1 over x is minus 1 over x square. Okay? Okay, good. So let's hope it works. It works. I like shifting this up. It's nice. Let's look at next important result. So I want to take derivative of x to the minus n. Okay, where n this time is negative. So earlier we have done for positive n. So what we want to know is d over dx x to the n, where n is a negative integer. You like with this side or with the front?
This side is better.
This is better?
Yes.
Okay. Where n is a negative integer. Okay. Okay, so what I'll do is, yeah, so I will write this as, I will write n as minus n, where m is positive. M is positive integer, right? If n is negative, then I can always write it as minus m. Is that okay? So let's say n is minus 2, then if m will be 2. So what's the derivative? D over dx x to the n is equal to d over dx x to the minus m, okay, where this is the relation, and now m is positive, is equal to d over dx 1 over x to the m. Agreed? Same thing, nothing spectacular has been done. Now I'll use the definition of derivative, meaning evaluate this function at x plus h and x. Take the difference, divide by h, take the limit h going to 0. So what is that? 1 over x plus h power m minus 1 over x to the m divided by h. Whenever I am writing h, I want to cut it. I want to write h bar. Okay, my habit of writing h bar. So you don't know? You don't know this? Okay, of course you don't know this. You are too young to know that. That is Planck's constant divided by 2 pi. Don't worry, don't worry. 2 pi or 4 pi? 2 pi. Okay, so this is, I'll just continue from this side. So this is, again I'll repeat similar steps. That's x to the m minus x plus h to the power m divided by x to the m x plus h to the m. Agreed? Now see, again numerator will go to 0 as h goes to 0. That's, of course, by construction it will happen. Oh, I really put h bar here this time. Is there a way to erase? Okay. Now this, and remember we have to take h going to 0 limit always, huh? So I should, you can write it yourself. I have to so this is not correct. Okay, I have to say h going to 0 limit. In the limit h going to 0. for all the steps. So this is, now you will recall what we did when we were looking at the derivative of x to the n, where n was positive integer. The same thing we can do. So it's 1 over h x to the m minus